Hello, in this video I'm going to talk about the standard normal model Z. Now we want to compare the unlike event. Even if two events are quite different, we can still compare them using the standard deviation as a ruler. We can see how many standard deviation each event is away from its mean. Assuming that on the average rainfall in Portland is 40 inches per year with a standard deviation 8 inches. So that means in Portland, I'm going to let X be the rainfall of Portland. And we know that, I'm going to write that in here. It's going to be normal distribution, 40, with standard deviation of 8. And assuming that the average wind speed in Chicago is 10 miles per hour with a standard deviation of 2 miles per hour. I'm going to use different letter Y. Y stands for the wind speed in Chicago. Follow normal distribution with a standard mean is 10 miles per hour and standard deviation is 2 miles per hour. Suppose that 1 year Portland annual rainfall was only 24 inches and the Chicago's average wind speed was 13 miles per hour. Which of these events are more extraordinary? More extraordinary means which event is further away from the center or from the mean. Okay, so it's very hard for us to compare to these two data. If you draw the number 9, you might end up to have something. Okay, and then when it comes to 40, so Portland may look like a big bell curve, and then Chicago might look like something very small. So how do you compare these two? Then we're going to use a z-score, which is to help you to scale down or scale up your normal distribution model so that they're more comparable. So the z-score formula is z-score is equal to the x subtract the mu divided by the sigma. To compare them, basically what they call this step is called standardize, which is scale down them to the same level, standardize the z. Okay, so now Portland is 24 inches. We know that that year is 24 inches. So that means our x is equal to 24. So the z-score for Portland in that specific year is 24, subtract the mu, which is 40, and then divided by 8. So, which is equal to -2. So, z-score equals to -2 means that rainfall is 2 standard deviation away from the center. We don't really care about if it's positive or negative. We care about the distance, how far away from the mean. It just negative means it's on the left side of the mean. Now look at the z-score of the Chicago wind speed. So the wind speed is 13 miles per hour on that year. So the z-score for that is 13 subtract 10. Subtract its own mean divided by 2. So we have 3 divided by 2, which is 1.5. So that means z is equal to 1.5 means that wind speed in that year is 1.5 standard deviation away from the mean. So now tell me, which one do you think is more extraordinary? Definitely with a bigger standard deviation. So that means we can write down our conclusion. Portland Portland's rainfall in that year is further away from the center, from mean, which is more extraordinary. Okay, so z-score basically is a standard normal distribution with the mean, population mean is 0, and the standard deviation is 1. So when we join the normal model, it's going to be the standard 0, 1 standard deviation away, 2 standard deviation away, 3 standard deviation away. It just happened to be the standard deviation is equal to 1. So here's -1 and -3. The rest is the same. The total area is also 100% within 1 standard deviation is 68%, and then 2 standard deviation is 95%. Okay, standardizing into z-score doesn't change the shape of the distribution of the variables. So like I say, basically is scale up or down, or they just magnify proportionally. It doesn't change the center by making the mean, changes the center by making it equal to 0, change the spread by making the standard deviation 1. Also, the normal distribution model is one model that continuous distribution of population is identified as a bell curve. Normal model are only appropriate for distribution that is symmetric and a unit model, and also has a mean of the standard normal distribution, the standard one, which is we use z, with the mean equals to 0 and 1, which is this is the model. In general, the standard normal distribution is denoted with n normal distribution with mean and sigma. So z-score is equal to the x subtract the mu and sigma. For example, find the p probability of the z less than or equal to 1.5. So if they say z, that means this is going to be a standard normal distribution. Okay, now let's use GeoGebra. We change it here to be 0. And sigma is equal to 1. And we want this to be less than 1.5. So we change the letter to 1.5. So we got less than. Should be this part. So it should be 93.32%. So that means this is equal to 0.9332 or 93.32%. Second one, find the p between -0.3 to 0.5. Same deal. We will have a mean with 0, sigma equal to 1, and then in between would be 0.3, -0.3, and the positive 0.5. So that would be 0.3094. Or 30.94%. All right. Here's the next example. A incoming freshman took her college placement exam in French and mathematics. In French, she scored 82, and in math, she scored 86. The overall result on the French exam had a mean of 72 points and the standard deviation of 8 points, while the mean math score was 68 with a standard deviation of 12 points. On which exam that did she do better compared with the other freshmen? So on the school data or the other freshmen, we know that the French one follow a normal distribution with a mean of 72 points and a standard deviation of 8 points. For the math, I'm going to use the letter N, and then follow the normal distribution of 68, and then the deviation is 12. The mean is 68, the deviation is 12. So we know that she took, it looks like, oh, she might do better in math because she's 86%, and her French is 82, it's less. But we don't know because they're on a different scale. So it's better for us to check it out with the z-score. Okay, for the z-score, in the French class, we know that her French is 82. So that means 82 subtract the mean, 72, divided by 8 is equal to 10 divided by 8, which is 1.25. That means she is 1.25 standard deviation above the mean. Since it's positive, so it's above. And for the math, z-score is equal to her score 86 subtract 68 divided by 12. And here is equal to 18 divided by 12, which is 1.5. So she is 1.5 standard deviation above the average, or the center, or the average of other freshmen. So that means her math is better than her French. So she does better on math compared with other freshmen. Yeah, so here's how we use z-score to compare two different scales of normal model. So let me know if you have other questions.